Good morning, everyone, and welcome to the Q&I summer course. So students, I'm Sunit Kumar, your mathematics teacher. And students, we were doing polynomials in the previous class. We started with the chapter polynomials, and today we'll continue with the second lecture of this chapter. Let's start the class. So as I said, we'll continue with this chapter polynomials. Today is our second lecture. And students, prerequisite for today's classes, you should understand algebraic expressions. You should know what are the different types of polynomials, and outline for today's classes. We'll study about value of a polynomial. We'll learn how to find the value of a polynomial at a particular value of a variable. And second, we are also going to learn how to find the zeros of a polynomial. So these are the two things which we are going to learn today, which we are going to understand today. So first of all, first topic. Rudra, can I take these doubts while we start practicing? I'll check it and then we'll let you know. Okay. There may be an error. We will correct it. Right. So let me just check it after the class. Thank you. Yeah. So value of a polynomial. What value of a polynomial means? If Px is a polynomial and alpha is any number, right? Then the real number obtained by replacing x by alpha in Px is called the value of Px at x is equal to alpha, and it is denoted by P alpha. So what it means, let us understand. So let's say we have a polynomial Px is equal to 5x square plus 2x plus 1. And let's say we have to find the value of polynomial. So value of polynomial Px at x is equal to 2 will be represented by, we'll replace x by 2. So value of the polynomial at x is equal to 2 is P of 2. So what we need to do, we are going to put the value instead of x, we are going to put the value as 2. So P of 2 is equal to 5 into, wherever we have x, we'll replace it by 2. So 5 into 2 square, because it was x square, we'll replace it by 2 square, plus 2 into 2 plus of 1. So P of 2 means wherever we had x, we will replace it by x is equal to 2. So value of the polynomial at x is equal to 2 is P of 2. P of 2 means, it is the way you read it out, right? P of 2 means P of x is the polynomial. P of 2 means wherever you have x, you will replace it by 2. So when you replace it by 2, you have 5 into 4 plus 2 into 2 is 4 plus of 1. So 5 into 4 is 20 plus 4 plus 1, which is 25. Ane, what we are talking about is the value of the polynomial at a value of a variable. So since the polynomial which we have defined here is px, px doesn't mean that it is multiplication or something. Px means it is representation. P stands for polynomial. Any polynomial can be named by some letter. So let us say we have named this polynomial by the letter p, and x denotes that what is the variable which we are using in that polynomial. So let's say we have used this variable x in the polynomial 5x square plus 2x plus 1. This is an algebraic expression, and we know that this algebraic expression, because the powers of x are positive integers, that's why this is a polynomial. Right? Now this polynomial, if we have to find the value of the polynomial at x, at some particular value of x or some particular value of the variable, we say that at x is equal to 2, the value of the polynomial will be p2. Instead of px, we write it as p2. So wherever we have x, we will replace x by 2. So 5 into 2 square plus 2 into 2 plus 1. So this is 20 plus 4 plus 1, that is 25. This is what the value of the polynomial means. Is it clear? Anna, is it clear now?
Yes.
Okay. Shall I move ahead? I'll give you one more example. Let us do 3, 4 examples. See, these are new things which you are learning it, means which you are seeing it for the first time. So there may be confusion ki why am I writing it like that? But these are the basics. These are the basic concept which we have to take it as is. So because p of x is some polynomial, if we are going to find the value of the polynomial at some value of x, we will replace that value of x wherever we have x here in the polynomial. Okay, so I'll just quickly rub this, take few more examples so that you are more confident before we actually start doing the questions based on finding the value of the polynomial at some value of the polynomial, some value of the variable. For example, let's say now I say that p of y is y cube plus y square minus y plus 1. Let's say this is another polynomial. Okay. Now, if we have to find value of py at y is equal to, for example, 3. So we have to find the value of the polynomial py at y is equal to 3. So we will represent this as p3. Instead of y, we'll write 3. And wherever in the polynomial we have y, we'll replace it by 3. So we have 3 cube plus 3 square minus 3 plus 1. So this is 3 cube is 3 into 3 into 3, 27. 3 into 3 is 9 minus 3 plus 1. So 36 minus 3 is 33 plus 1 is 34. So P of 3 is 34 here. Is it clear to everyone what the value of the polynomial means? Wherever you have a variable, just replace that variable by the value of that variable and then calculate the final value and you will get the value of the polynomial at that particular value of the variable. Correct? Is it clear? Is it clear to everyone? Yes, Anna, I'll give you 3 more examples. We'll do some more examples in the next slide. Is this concept clear to everyone? Subhranshu, Hana, Rudra, Neha, Laksh, Arush, Samagna, and Arsh. There are few students who are very quiet. They don't write or respond, right? Okay, let's go to the next one now. So here we are doing 3 examples. We have to find the value of each of the following polynomials at the indicated value of variable. So first one is px, if it is 5x square minus 3x plus 7, find the value of this polynomial at x is equal to 1. Means you have to find p of 1 here in the first.
9.
Yes, correct. It is 9.
Hi,
Correct.
9, 9.
Yes, it is 9. So px was 5x square minus 3x plus 7. Now, if we have to find the value of p1, that is value of the polynomial at x is equal to 1, we will replace x by 1, 5 into 1 square minus 3 into 1 plus of 7. So this is 5 minus 3 plus of 7. So 12 minus 3, which is equal to 9. Clear?
Yes, sir.
Can you do the second one? You have a polynomial qy, 3y cube minus 4y plus root 11. You have to find the value at y is equal to 2. Yes, Anna, it is correct.
Sir, 16 plus root 11.
Yes, correct. Arush, it is correct. Subhranshu, yes, it is correct. Good, good, good. So the polynomial qy was 3y cube minus 4y plus root 11. And if we have to find the value at y is equal to 2, so you will have q of 2 is 3 times 2 cube, 4 times 2 plus root 11. So 8 threes are 24 minus, sorry, 8 threes are 24 minus 8 plus root 11. So this is 16 plus root 11. Third one,
Third one will be 4 a to the power 4 plus 5 a to the power 3 minus a to the power 2 plus 6.
yes, very good. So third part is P of t is 4t4 plus 5t cube minus of t square plus 6. You have to find the value at t is equal to a. So P of a, simply replace t by a. So this will become 4a4 plus 5a cube minus a square plus 6. This is P of a. Yes, Anay, correct. We have to just replace all the values, all the t's with a. So that will give you P of a. Is it clear? Shall we go ahead? Okay. Now 0 of a polynomial. What does 0 of a polynomial means? So that value of the variable which makes the value of the polynomial equal to 0 is called the 0 of a polynomial, right? So a real number alpha is a 0 or root of a polynomial if polynomial px if p of alpha is equal to 0. So finding a 0 of a polynomial px means solving the polynomial equation px is equal to 0. Solve it for x and you will get the 0 of the polynomial, right? Now, what does this mean? So you can write 0 of a polynomial is that value of the variable which makes the value of the polynomial equal to 0, right? So 0 of a polynomial is that value of the variable which makes the value of the polynomial equal to 0. So if x is equal to alpha makes the value of the polynomial p alpha equal to 0, then we say that x is equal to alpha is the 0 of the polynomial. So to find the 0 of a polynomial, what we do is we equate that polynomial with 0 and get the value of x which satisfies this equation. Okay. For example, if we have an equation 5x minus 3, if we have a polynomial px 5x minus 3, if we have to find the 0 of this polynomial, we will equate this to 0, solve it for x. So 5x minus 3 is 0 means 5x is 3 or x will be equal to 3 over 5. So 3 over 5 is the 0 of the polynomial. So 0 of px is 3 by 5. So when we put the value of x as 3 by 5, we will get the value of the polynomial equal to 0. That's why x is equal to 3 by 5 is the 0 of this polynomial. Now, a non-zero constant polynomial has no 0. For example, we have a constant polynomial px is equal to 2. Now, because there is no variable here, it is only a constant. If you equate, you can never get the value of this polynomial equal to 0 because px is 2, that is a constant. You cannot change the value of 2. It can never be equal to 0 and that's why non-zero constant polynomial has no 0. It will have no 0. Similarly, every real number is a 0 of a 0 polynomial. So let's say we have a polynomial px is equal to 0. This is called a 0 polynomial. Now this 0 polynomial will be always 0 for whatever value of x you take, right? So that's why every real number is a 0 of the 0 polynomial. So for constant, non-zero constant polynomial, there will be no 0. And for a zero polynomial, there will be all real numbers will be the zero of this polynomial. Are these 2 points clear to everyone? Okay. Now, if we have, so let us take one more general case. So a linear polynomial. So if you have a linear polynomial, the linear polynomial general form of the linear polynomial is ax plus b, right? Where a and b are constant and x is the variable. So for this linear polynomial, if you have to find the zero here, so if px is equal to ax plus b, equate it to 0, you will get ax is equal to minus b or x is equal to minus b over a. So x is equal to minus b over a is the zero of the polynomial. Is it clear? So this is a general case. So you bring the constant on the other side, divide by the coefficient of the x of the variable, and you will get the value of the zero of the polynomial. Is it clear to everyone? You also need to know that here a is not equal to 0 because the denominator cannot be 0. So is it clear to Neha, Aditi, Subhranshu, everyone? Ana, Rudra, Laksh, Ars and Samagna? Yeah, okay, good, thank you. Now, in this question, students, we have to check whether -2 and 2 are zeros of the polynomial x plus 2 or not. To check that, we replace the value of x by these values and see whether the answer is coming to be 0 or not. So the polynomial is given as px is equal to x plus 2. Now we have to check -2 if it is a 0. So what we'll do, p of -2 is -2 plus 2, which is equal to 0, right? So that means x is equal to -2 is a 0 of the polynomial, right? Because it gives the value. Yes, Anay, correct. Anay and Rudra, correct. And for p of 2, we will get 2 plus 2 equal to 4, which is not equal to 0. So x is equal to 2 is not a 0 of the polynomial. Correct? Yes, Arus, it is same answer as these students. You have to type your own answer. You don't have to say that the answers which they have given is the same. Okay. Okay, let's move to the next question then. Clear to everyone? Find a zero of the polynomial px is equal to 2x plus 1. So this is similar to ax plus b. What will be the zero here? Equate it to 0, solve it for x, you will get the zero of the polynomial. Okay, good. So x is equal to -1 by 2 is the answer. Yes, Arush, you don't need to copy. So find the zero of the polynomial px is equal to 2x plus 1. To find the zero, Just equate it to 0, solve it for x. So you will get 2x is equal to minus 1, x is equal to minus 1 by 2. So x is equal to minus 1 by 2 is the 0 of the given polynomial. Correct? Okay, let's go to the next now. We have to verify whether 2 and 0 are the zeros of the polynomial or not. So we'll have to check it for both the value of the variable. Okay. So the polynomial px is given as x square minus 2x. To check whether x is equal to 2 is a 0 or not, we'll put p of 2, 2 square minus 2 into 2, 4 minus 4, which is 0. So that means x is equal to 2 is a 0 of the given polynomial. Similarly, p of 0 is 0 square minus 2 into 0, 0 minus 0, which is 0. So x is equal to 0 is also a 0 of the polynomial. Correct? Both 2 and 0 are zeros of the polynomial. Correct. Arush and Rud, both of you are correct. Is it clear, students? Have you noted this down? Okay, let's move ahead. Now, there are certain facts which you need to understand. A zero of a polynomial need not be 0. So it is not necessary that 0 of a polynomial has to be 0. No. It can be any value which satisfies that polynomial and makes that polynomial's value equal to 0. So value of the variable can be anything. X is equal to 1, 2, 3, anything. It is not needed to be 0. Second, 0 may be a 0 of the polynomial, as we saw in the last thing. Okay. So 0 of a polynomial, 0 may be a 0 of the polynomial. So for example, we saw it in the last case, previous case, if we have a polynomial 3x minus 2x square. So here we can see that if we put the value of x as 0, right, you will get the value of the polynomial 0. So x is equal to 0 is the 0 of a polynomial. So 0 may be a 0 of the polynomial. That is what they mean to say. Every linear polynomial has one and only one 0. And that we already saw that if the polynomial px is equal to ax plus b, the 0 x was equal to minus b by a is the 0 of the polynomial. Okay. Now a polynomial can have more than one 0, right? We also saw that if the degree of the polynomial is more than 1, if the degree is 2, 3, 4, so you will have more than one zeros. If it is a linear polynomial, then it has only one 0. If the degree of the polynomial is more than 1, then we have more than one zeros. Okay. Now we have to find the value of the polynomials at different values of x. So in the first case, the value of the polynomial px is equal to 5x minus 4x square plus 3. So we have to find the value at x is equal to 0. So p of 0 will be 5 times 0 square. Yes, the answer is 3. 5 times 0 square minus 5 times 0, 5x minus 4x square plus 3. So this is 0 minus 0 plus 3, which is equal to 3. Yes, Harus, it is correct for the second one as well. So second one, p of minus 1 will be 5 into minus 1 minus 4 into minus 1 square plus of 3. Okay. So this is -5 -4 plus 2, right? So -5 and -4. Okay, this is 3. I'm sorry. So -9 plus 3, which is equal to -6, right? And for the third, -3 is the correct answer. Yes. So P of 2 will be equal to 5 into 2, 4 into 2 square plus of 3, 10 minus 16 plus of 3, 13 minus 16 is -3. So -3 is the correct answer. So yes, Rudra, Arush, -3 is the correct answer for the third one. Okay. So let's move to the next question now. I hope everyone else is understanding and they are also noting it down. So find P0, P1 and P2 for each of the following polynomials. Py is equal to y square minus y plus 1 and Pt is 2 plus t plus 2t square minus t cube. So first one, P of y is y square minus y plus 1. So you have to find different values of the polynomial at different values of the variable. Yes, correct. Ane. So P of 0 is 0 square minus 0 plus 1, which is 1. P of 1 is 1 square minus 1 plus 1, which is again 1. And P of 2 is 2 square minus 2 plus 1. So 4 minus 2 is 2 plus 1, 3. So 1, 1 and 3 are the answers for P0, P1 and P2. Yes. Aditi, Samagna, Arush, correct answers. Now P of t is equal to 2 plus t plus 2t square minus t cube, right? Now let us put the values of t here. So we have P of 0, we have to calculate. P of 0 is 2 plus 0 plus 2 into 0 square minus 0 cube. So which is 2. Yes, correct. P of 1 is 4. Yes. P of 1 is 2 plus 1 plus 2 into 1 square minus 1. So this will be 5 minus 1, that is 4. And P of 2 is 2 plus 2 plus 2 times 2 square minus 2 cube. So 8 minus 8, so is gone, which is 4. P of 2 is 4. Yes, Rudra, correct. Arush, Aditi, correct. Samagni, you are also correct. Is it clear, students? Has everyone noted this down? Okay. Now again in this third and fourth part, you have to find P0, P1 and P2. So third part, P of x is equal to x cube. So P of 0 is 0 cube, which is 0. Yes, correct. P of 1 is 1 cube, which is 1. P of 2 is 2 cube, which is 8. Yes, correct. Now for the fourth one, we have Px is x minus 1 into x plus 1. So P of 0 will be 0 minus 1 into 0 plus 1, that is minus 1. Okay. And then P of 1 is 1 minus 1 into 1 plus 1. So this is 0 into 2, that is 0. And P of 2 is 2 minus 1 into 2 plus 1. So which is 1 into 3, that is 3. Is it clear? Okay, let's go to the next now. Now here we have to verify whether the following are zeros of the polynomial indicated against them. So px is equal to 3x plus 1. You have to check it for x is equal to minus 1 by 3 whether it is a 0 or not. So first part, p of minus 1 by 3 will give you 3 into minus 1 by 3 plus of 1. So this gets cancelled. So minus 1 plus 1, which is 0. So yes, x is equal to minus 1 by 3 is a 0 of the polynomial. Okay. Check it for second one. Yes, Anay, correct. It is not a 0. So p of 4 by 5 in the second one will be 5 into 4 by 5 minus pi. This gets cancelled. 4 minus pi. Since it is not equal to 0, so that's why it is not a 0 of the polynomial. Clear? Yes, Rudra, correct. 4 by 5 is not the 0 of the polynomial. Now check it for 1 and minus 1 and minus 1 and 2. So p of 1 is 1 square minus 1, which is 0. And p of minus 1 is also minus 1 square minus 1. Again, it is 0. So yes, it is 1 and minus 1. Both are the 0 of this polynomial. Yes, correct. Anay, Arush. Fourth part, p of minus 1 will be minus 1 plus 1 and minus 1 minus 2. So minus 1 plus 1 is 0 minus 3. 0 into minus 3, that is 0. And p of 2 is 2 plus 1 into 2 minus 2. So 3 into 0, which is 0. So yes, it is 0 for both minus 1 and 2. Clear? Yes, Rudra, correct. Let's go to the next one now. Verify whether the following are zeros of the polynomial indicated against them. So fifth one, we know that p of 0 is equal to 0 square, which is 0. So yes, it is a 0 of the polynomial. Sixth one, p of minus m by l is l times minus m by l plus of m. So l and l gone, minus m plus m, which is equal to 0. So yes, it is a 0 of the polynomial. Minus m by l is 0 of the polynomial. Correct? Yeah, polynomial px is lx plus m. And yes, it is a 0 of the polynomial. Correct, Rudra. Now here in this question, verify. Again, you have to verify for minus 1 by root 3 and 2 by root 3 both. Okay. So p of minus 1 by root 3 will be 3 into minus 1 by root 3 square minus 1, 3x square minus 1. So 3 times 1 by 3 minus 1. So this gone, 1 minus 1 is 0. So minus 1 by root 3 is a zero of the polynomial. And you have to check it for 2 by root 3 as well. So 3 into 2 by root 3 whole square minus of 1 is equal to 3 into 4 by 3 minus 1. 4 minus 1 is 3, not equal to 0. So that's why it is not a zero of polynomial. Clear? And which second one is 2? The value of 2 by root 3. So if you put the value of 2 by root 3, this will be 2 by root 3 whole square. So this is 4 by 3. 3 and 3 gets cancelled. 4 minus 1 is equal to 3 and not 2. Yeah. So the value of 1 by 2. So now eighth one if we do. So this was 7th. For eighth, P of 1 by 2 will be 2 times 1 by 2 plus of 1. So 1 by 2, 2 gone. 1 plus 1 is 2, not equal to 0. So no, this is not a zero of the polynomial. Okay. Okay, Ane. Got it. Is it clear to everyone? So students will stop here for the day and we'll go and practice on the platform. So let's log in on the platform and I'll tell you which uh, topic to practice. Samagn, you first we'll understand the basics of the chapter and then we'll understand where it is used in the real life. So in real life, basically, to find the zero of the polynomial gives you where the graph of that polynomial cuts the x-axis. All of this you are going to do in class 10th. And then further in 11th and 12th, you will also get to know why are we, learning about zeros and roots of a polynomial. Okay? And the value of the variable.